Hello there, this is Alana Tuckey, and this is going to be the lecture videos for section 7.2 of Math 131. Now in this section we're going to be talking about graphing quadratic functions that are in standard form, and then the vertex of quadratic functions. Very important ideas. So first of all, standard form is this form, where it's f of x equals ax squared plus bx plus c. Now keep in mind that's a different form than we worked with in 7.1. 7.1 had us dealing with the form f of x equals a times x minus h squared plus k. That's vertex form because the vertex is h comma k. But here, to find the vertex, we're going to have to use this formula right here. Now that's going to be more complicated. However, you do not have to memorize this formula for the vertex. That's something that I give to you on your formula sheet for both the third exam and the final. All right, so next, if a is greater than 0, that means your parabola opens upward. Remember, we learned that in the last section. So if a is greater than 0, the parabola opens up like this. And that means your vertex is going to be the minimum point. It's the very, very bottom. If a is negative, it means your parabola opens downward, which means your vertex is the very tip top of that graph. So it's the maximum. So that's what we put right here. All right, now for this problem, let's see, f of x equals negative x squared minus 6x minus 4. So a is negative 1, b is negative 6, and c is negative 4. So it's always that a is the one that's in front of the x squared, the coefficient in front of the x squared, called the leading coefficient. B is the coefficient of the x term, and C is the constant. All right, so now we're going to find the vertex by hand. So first thing we're going to have to do is find x. X is negative b over 2a. Okay, so that's negative, negative 6 over 2 times negative 1. So there's your b right there, which is negative 6, and there's your a, which is negative 1. Okay, negative 6 is positive 6. 2 times negative 1 is negative 2. And that means our result is negative 3. So there's our x value right there. But a vertex is a point. So it's not enough just to have the x value. You need the y value that goes with it. So to find the y value, you're going to have to take negative b over 2a and plug it back into the function f. Okay, so we're going to take our negative 3, and we're going to find f of negative 3. That'll be our y. Let me put it over here. Y equals. All right, so this is negative, parentheses, negative 3 squared minus 6 times negative 3, take away 4. Right? That's what happens when you substitute negative 3 in. Put parentheses around it, especially when you're substituting with a negative. You put parentheses around it to keep the negatives clear. All right, so this is negative 3 squared is 9. So this is negative 9. Negative 6 times negative 3 is plus 18. Take away 4. So that would be 5. Right there. And I just did that in my head. But of course, you could use the calculator to help yourself if you needed to. You would just type, let's see, quit. Negative parentheses negative 3 close parentheses squared minus 6 times negative 3 minus 4. And sure enough, you get 5. Okay, so there's that. So our vertex which is what we were really looking for, is negative 3 comma 5. And there's our result. We have found it by hand. Now, would that be a minimum or a maximum point? Explain. Okay, so look at your A, right? If A is negative, then it's a parabola that opens downward, which means it's a maximum. If A is positive, then the parabola opens upward and the vertex is a minimum. So for our case, A is negative 1 right here. A is negative 1. So that means that this is a maximum. I'm just typing that up. Therefore, the vertex is a maximum. All right. All right, and I just wanted to draw you a quick little sketch so you could see it. So you have a graph that's over -3, up 5 for the vertex. Since it's opening downward, and this is just a quick sketch, this isn't to scale or anything, but you get the idea. Since it's opening downward, that vertex is a maximum. It's at the tip top. Now let's see if I can verify that also with the calculator, and I wanted to just real quick run through how to find that with your calculator. So clear. Negative x squared minus 6x, and there's more in-depth instructions right in the calculator tutorials. So you hit, let's see, zoom 6. I'll get a regular window for it. There it goes. And then I'm going to do second calc. And then, oops, second calc. Hit number 4, which is maximum. You got to move to the left of your maximum. So get your blinky cursor thing over to the left. You need left bound. So you need to be the left of that peak and hit enter. Now move to the right of the peak. So go over to the right, hit enter, and hit enter. It's fine. And there you go. Now notice the calculator messes up down here. You've got to know, oh, that's just a rounding issue. It's really -3. Okay? All right. And again, there are more in-depth instructions at this link down here. All right. So there's that. Now we're going to do it again. So we're going to have to find the vertex by hand of this equation, this function. So x equals -b over 2a. Okay. So b in our case was 4. So this is -4 over 2 times -1/2, right? There was -1/2 as your a. And the negative doesn't really matter if you want to put it in front or if you want to put it up on top. I think it's easier to read when it's up on top. Okay, so this is -4, and 2 times -1/2 would be -1. So this would be 4. So there's your x coordinate right there. Now you're going to take 4 and substitute it back in the problem to find the y to go with it. There we go. So y would be f of 4, which would be negative. Again, I like the fraction with -1 on top. It's just easier to read. -1/2. And then instead of x, you're going to write 4. So 4 squared plus 4 times 4 minus 10. Okay. So we want to find what this is. And either we have to do this in our head or we can use the calculator to help us. It's -8 plus 16 minus 10. So I think it's going to be -2, but let's see. So quit. -1/2 times 4 squared minus, plus 4 times 4 minus 10. And there we go, -2. I did do it correctly in my head. All right, so -2, oopsie. There we go, down there. -2, there's our y value. Okay, so now we know the x and the y, then we know the vertex. The vertex is 4, -2. And there we have it. All right, so we found that by hand as requested. Oop, there it is. Okay, so now is that a minimum or maximum? Well, just as before, it's a maximum because this is a parabola that faces downward. In fact, I could copy it verbatim from what I said before. Since a is negative or less than 0, it is a maximum. There. And we're actually going to graph it. So we'll know whether it's truly or not because we are about to figure it out. If I could get this all to fit on one page. There we had it. Okay, so now it wants us to place the vertex in the middle of this table and place them in the table by hand, then graph. Okay, so in the middle of the table, I'm going to put the vertex, which is 4, -2. And now I'm going to fill out a whole bunch of other points. Now, the intelligent way to do this would be to use the calculator, right? Because it can help me find a whole bunch of points. Let me go to y equals, clear this out, type -1/2 x squared minus, oh rats, what was it? Oh, plus 4x, that's it. Plus 4x minus 10. Okay. Now if I go to the table, which is above the graph button, and I kind of look around, I know that 4, -2 is my vertex. So I can start seeing some other points that actually fit in the grid. I'm not going to bother with the half points, the ones that get me like 6.5 or whatever. That's not worth my time. But -220, that would work. 0, -10, that would work. 2, -4, that would work, and so on. So let's fill those out. Oops, I keep going back to that screen. All right, so 2 went with -4. 0 goes with -10. And -2 goes with -20. Again, you don't have to pick these points, but it's easy to pick these points because they're on the grid. They actually fit on the grid. And then see, 4, 6, 8 went with -10, and 10 goes with -20. All right, so we graph these points and put them on this grid. And there's the graph right there. All right, so what's the domain? Well, I can't make it show it to you in the graph that the graphing program I'm using, but there are little arrows on the end of this. Now remember that domain is left to right. So you want to go as far left as the graph can go to how far right the graph can go. But the graph never really stops. It always goes left to right, okay? So you're going to want to give it parentheses, -infinity, comma, infinity. It goes left forever to right forever. Simple as that. Now the range is a little bit different. Range is low to high. So obviously it goes forever in the low direction because there's little arrows down here at the ends. Okay, so -infinity again. But you want to get all the way up to -2, and you actually get to hit -2. So you're going to write that a little bit differently. There you go. -infinity, comma, -2. And -2 actually gets a solid bracket because you actually get to it. And so notice our vertex really does back up what we said it would. This is a parabola, it's opening downward, and the vertex is the maximum right up there. All right, so we're done with this question, and I'll see you back here for the part 2 video where I will go over this story problem. So I'll see you then.